Okay, it's been a lot of work leading up to this point, but we have a Spark program that should give us similar movies to each other just by looking at some movie ratings data that users have put in. So we'll figure out what movies are similar to each other just based on similarities between user ratings. Let's run it and take a look at the results. All right, let's turn this movie similarities problem into some real code. And go to the resources for this lecture. You will find a movie similarities script. So go ahead and download that to your Spark course folder. Hit pause and come back when you're done, and we'll open that back up. We're going to keep on using the Movie Lens 100,000 rating data set for this example as well, so there's no new data to download, just the script. All right, this is, the most complicated thing we're going to do in this course, so let's just get through this script and walk through what it's doing. We described it at a high level in the previous lecture, but let's go through it again. So, we're going to be importing the usual stuff. We do need to import the square root function from the math package in Python as well, so we can do our similarity metric and compute similarities later on. But let's skip down to the meat of it. So we create our Spark context, and again, we're doing this with a local star master argument here, and that means that we're actually going to use Spark's built-in cluster manager and treat every core on your desktop as a node on a cluster. So for the first time, we're going to be running on more than one process, and you actually kind of need it for this problem. Next, we'll load up the dictionary of movie names. We've seen that before. So if we look at the load movie name script, it's just returning a Python dictionary that maps movie IDs to human readable movie names so we can look at them more easily. And we're using the usual decode trick to make sure that we can actually display them in our terminal here. That's all that decode stuff is doing. Now, we're not going to muck around with broadcast variables in this particular example. We're just going to use that dictionary at the very end when we're doing our final display. Okay, so keeping that a little bit simpler. All right, we'll load up our source data of movie ratings data. Again, the u.data format is user ID, movie ID, rating timestamp, and that goes into a data RDD. We then do this big long operation here to map it into our initial pass here. So we start off by splitting the data on white space into individual fields, and then we map it again into the format we want. So this is going to give us back together an RDD that is user ID as the key, and the values will be these composite values of movie ID and rating. So we have a key value RDD at this point. Keys are user IDs, and the values are movie rating pairs. Next, we do a self-join operation to find every possible combination of movies that were rated together by the same user, okay? And that blows up really quickly. This is where most of the work is going to be happening in this script, because when you start looking at every possible combination, you're looking at factorial relationships here. It blows up like you wouldn't believe. But with Spark, we can actually do it because it's scalable. So at that point, we're going to end up with user ID still as the key, but then we're going to get lists of every movie ID rating pair that were viewed together by that user ID. So we have this huge RDD now where the keys are user IDs and the values are every possible combination of movie rating pairs that user watched together. Next, we need to eliminate duplicates, because out of those possible permutations, we're probably going to get the same movie twice, just in a different order, and we'll even get the same movie related to the same movie. And we need to filter all that junk out, because that's not helpful. So our filter duplicates map function up here simply enforces that we only return pairs where movie 1 is less than movie 2. So we enforce only one ordering of the movie pairs that are in sorted order, and we also eliminate pairs where the movie 1 is the same thing as movie 2, because that's not helpful either. So we talked about filters before. This is another example of using filter to reduce, well, reduce is probably a poor choice of words, but to cut down a large RDD into a smaller one by throwing away information you don't want. Okay, so now we have a cleaned up RDD that contains every movie rating pair, every movie pair for each user. Now, next, where were we? We filtered out the duplicates. Now we need to shuffle things around. So what we care about in the end is the similarities between pairs of movies, between unique pairs of movies, okay? So we're just going to run another map operation on that to make the new key the movie pair itself, and that's what the make pairs map function does. Up here, it extracts the movie and rating for each pair of the input RDD and outputs a new key value RDD where the key is the movie pair and the value are the ratings for that movie pair. All right, we're almost done. Now we're going to do group by key to actually get together all the rating pairs for each unique movie pair. So for every pair of movies, we gather together all the pairs of ratings from every user that watched that pair of movies. And now that we have every set of ratings from every user that watched a given pair of movies, we can compute the similarity between those two movies by actually comparing the similarities between those two sets of ratings. And that's what compute cosine similarity does. I don't want to get too much into this from a mathematical standpoint, but it is basically a metric of how similar two vectors are, in this case two vectors of ratings, and it uses that to determine a similarity score between these two movies. And as it is sort of a cosine-like function, a strong similarity will be a rather high number, close to 1.0, but less than 1.0. So 0.95-ish would be a good similarity, for example. And as we mentioned before in the previous lecture, we're going to cache that result because we're going to need to use that movie pair similarities RDD more than once. If you did not do that and you were to call more than one action on movie pair similarities, then you'd be in trouble. We'd have to go back and recompute it all over again, and that would be a shame. Now, if you want to, we could actually save the results to text files and go examine them offline later. And if you want to do that, you can uncomment these. And this is just a little example of how you can use the save as text file method to actually output the results to text files. Now, bear in mind, since we're running this from on my four core computer, we would get 4 different output files, right? So each individual executor will end up writing out its own results here. So you would have to combine those together by hand at the end. Just something to keep in mind. But for now, I'm going to introduce another concept. I'm actually going to take in an input parameter on this script that indicates the movie that I care about, that I want to get similarities for, and just extract the similarities for that one movie. So if I do provide an argument to this script, I am going to go look for that movie ID and run the filter operation to filter out only movies that actually include the movie that I am interested in. So let's say I pass in movie ID 50, which is Star Wars. I'm going to run another filter on my similarities results to extract only the similarities that include Star Wars in the pair. Okay? And furthermore, I'm going to introduce a minimum threshold on the quality of the similarity by saying I only want results that have a score greater than 0.97 and have at least 50 different people that watch the same pair, because that gives me more confidence in the quality of the results. If I were to allow similarities between movies that were only watched by 1 or 2 people, I'd get a lot of spurious results that didn't make sense. So that's a very important thing to take into account. Finally, I will sort the final result by key, by the quality score. So I do the usual trick here of flipping the key and value to actually get the thing I want to sort by in the key, and then sort by key, and I will actually do it in descending order and take the top 10. Okay, going through this a little bit quickly, but go back, look at it more closely on your own. It's mostly self-explanatory if you think through it, but that is a one-line way of flipping the RDD to sort it by the similarity score in reverse order and taking the top 10 results, and then I can just take those results and print them out. Okay. So let's go ahead and do it. Like I said, very complicated example, or most complicated that we'll see in this course. So if you need to go back and stare at it some more, please feel free to do so. Let's actually run it and see what happens. Spark-submit. What I call this thing again? Movie similarities. And remember, I need to take a parameter for the movie ID I care about, and as you recall, movie ID 50 is Star Wars, so let's use that as a well-known example. Off it goes. All right, we load the movie names lookup table, and off it goes. And you're going to see a bunch of stuff here that you haven't seen before, because we're actually running this using Spark's built-in cluster manager this time, remember? So it's actually going to give us how the cluster manager is progressing, where it's treating each core of my desktop computer as an individual executor node. Off it goes. Now it's going to take a little bit of time. We have 100,000 ratings, and remember that self-join is going to create an entry for every possible combination of movies that were watched together by the same person. So that ends up being a very large amount of data. But we're actually getting through it relatively quickly. There we are. Cool. So we have some real results here based on real data and real ratings, and it turns out that the top 10 similar movies for Star Wars, the first 2 are exactly what I would expect. The Empire Strikes Back and Return of the Jedi, and Raiders of the Lost Ark, not a bad choice either. 20,000 Leagues Under the Sea, I can go with that. Things start to get a little bit weird after that. I mean, to be honest though, I'm a Star Wars fan and I've seen a lot of these movies and I liked them. And a lot of these had to be taken within the context of 1998 as well, when this data set was published. So pretty good results. They're not awesome, but they're pretty good. So, let's talk about something you can do to try to make it better. That's an exercise for the reader, and there's a lot you can do. There's a whole art and even a science to making good movie similarities data. So let's dive into it a little bit more. And there you have it. We have some reasonable results for movie similarities out of this initial take at our program here. But there's more than one way to do it. This is just one technique, and there are definitely better techniques out there that you can use to improve the quality of your similarities even better. So in our next lecture, let's introduce a learning activity that has you dive in and do just that.